Elizabeth. I have a super busy week this week, so I thought I would do a little video lecture early this morning, and then I'll send them to you, and hopefully this will help, and then you can ask questions about it. So I saw the problems you sent me. The first one I want to look at is the global max and min, so I'm going to do them kind of backwards. I don't know why, just because that's the first one that popped into my head. So let's look at global max and mins. Okay, obviously I gotta get a better pen here. Let's see what's going on. Let's try this brown one. I like brown. Okay, so the question is there a global max or min? And I'm just gonna make up an interval and I'm not gonna do the question that you're being asked to do. I'm gonna do one very similar to it. Actually, the one we're gonna do is gonna be harder. But let's see. Is there a global max or min on the interval from, let's go, -1 to +3, open interval with parentheses, for f of x equals x squared plus, I'm gonna have to use my little brain here for a second, 4x minus 3. Okay, again, let me use my little brain to think, make sure that works. Yeah, that should work. Okay, so remember that whenever you hear anything like global maximums or minimums, or you're looking for maximum or minimums, excuse me, that means to find the derivative. Okay, so max or min, derivative. So the first thing we'll do here is we'll just find the derivative of the function we've got, which we're going to get 2x plus 4. Okay, that look good to you? Now, when we're finding maximums or minimums, the next step is to find the critical value. And remember that finding the critical value means to take your derivative and set it equal to 0. You know what, here I told you I was going to use my little brain to figure this out, and I screwed it up. So luckily, we can do things like this. Change this to a minus sign. Sorry about that. See, my brain doesn't work apparently early in the morning. Okay, so 2x minus 4 is our derivative. Okay, sorry about that. So we're going to take the 2x minus 4, and we're going to set it equal to 0. And then if we add the 4 and divide, we'll get x is equal to 2. Now, we know that that's a critical value, okay? So that's one of our critical values there. And it is in our interval, isn't it? Okay, so that's the other thing, is you gotta make sure that your critical value is in your interval. Now we just need to decide, is that critical value a maximum? So is it a maximum or is it a minimum? And one way to do that is to make little intervals and decide about increasing and decreasing. Okay, so if we go from -1 to 2, okay, starting from -1 and going to our critical value, and then from 2 to 3. Now this is called the first derivative test. First derivative test. Okay, so hopefully you have covered this. But what it says is that if on this interval the derivative is negative, then the function is decreasing. If on the interval it is positive, then the function is increasing. So we just need to take a number out of this interval and plug it into the derivative. So like a number like 0, plug it in there, we get a -4, right? So we know that the answer is negative. We don't even care that it's -4, we just care it's negative. Then a number in between 2 and 3, well, I didn't leave myself much room there, so like 2.5. If we multiply 2 times 2.5 and then subtract 4, this is going to end up being positive. So that means that the function goes from decreasing, negative means decreasing, positive means increasing. So what I want you to think about is the function is on the left-hand side from -1 to 2, it's decreasing. and then it hits the critical value, and then it starts increasing. So where it changes at the 2 from decreasing to increasing, what does that give us? It gives us a minimum, right? So we've got that global minimum at x equals 2. Now, the other thing to remember when we're talking about global means that this is the absolute maximum or the absolute minimum. And if your intervals are open, like they are in your case, you don't include them as your global. So I know it looks like that we are going to have a maximum here on either, well, I don't even know which one is bigger or taller, but it looks like we should have a maximum, but with open intervals, there will be no maximum. It will just be this minimum. Okay, does that make sense? Okay, so we did this with a function that's far different, more difficult than the one that you're being asked to do it with, and I changed the interval. So now go back to your easier function, which I believe was just x squared. Use your interval, but follow the same steps and see if you can figure out whether you have a global max or a global minimum. And remember to make sure that your critical value is in your interval. That 2 was in our interval. Okay, that's your first and foremost. It must be in the interval. If it's not, problem's done, you move on. Okay? It's cold in the barn. So anyway, so there's that one. Let me make sure that it looks good. Okay, perfect.